Hello everyone, welcome back to Professor T. Today we are starting our system design series with one of the most fundamental topics, that is monolithic architecture versus microservices architecture. So let's dive deep into it. Now, what exactly is system design? A system design is the blueprint behind how large scale applications work. Whenever you open Netflix, Amazon, Instagram, or any big platform, system design decides how everything is structured behind the scenes. Now, a good architecture balances scalability, maintainability, performance, and complexity to deliver sustainable solutions. Now, what is monolithic architecture? So, monolithic architecture, you can say that it is the simplest model of any form of application. Now, a monolithic architecture is a single unified code base where everything API, business logic, database layer, authentication, background jobs all live together in one application. Now, imagine that there's a house, but the house is built from a single giant block, like via carving and stuff. Everything is connected and everything is one single piece. That exactly is what monolithic architecture means. Now, a monolithic architecture basically has one server and one user interface, which means there is a server and the server is interacting with a client. How they're interacting is when, for example, if client sends a request to the server, which is basically via an API, then the server returns with a response. This is the entire architecture known as the monolithic architecture. Now, let's see what the pros and cons of a monolithic architecture is. Now, monolithic architectures are basically easier to build as compared to a microservices architecture. They're simple to deploy as everything is in one place, one file, one server. Now, just because everything is situated in one place, it is easy to debug as well because the bugs will generally often in the single space that you have written your code in. They are perfect for small teams, and when you require your projects to be completed at a faster pace, you generally go for a monolithic architecture. Now, the cons of monolithic architecture is that as the project grows, the code becomes messy. Any small change, let's say if you are going to add a new feature or you're going to change something in your code, it requires a complete redeployment of the entire application. Now, when in the earlier stage, when you are in the development and you just released your application or you just deployed an application, in the earlier stage, it is fine because less number of traffic won't affect your architecture or your application. But when the traffic grows in your application, it will be more difficult to scale the individual parts or the individual features in your monolithic architecture application. Now, monolithic architecture has one single point of failure. So, for example, in any part of the monolithic architecture fails, the entire application fails. Now comes the microservices architecture. Now, architecture basically means that the entire application is split into independent, small, focused services. Each service has its own responsibility, its own deployment, and sometimes even its own database. Think of it like building a house, but with individual bricks. Now, if one brick has an issue or one compartment has an issue, you change the compartment, not the entire house. As you can see, what are microservices? Decomposition, breaking applications into small independent services focused on specific business functions. Then, next, the communication. The services that we create have to interact with each other. There are two methods to doing so, synchronous and asynchronous, which we will learn later on. Now, independence. Each service can be developed, deployed, and scaled autonomously. Modularity enables flexibility and agility in large complex systems. Now, let's see the pros and cons of microservice architecture. The advantages are they're independently scalable. So, any service can be individually scaled based on demand. Now, they are fault isolation, which means that if, let's say, if there are four microservices in your application, and if any one service fails, then the rest three will work. So, it won't crash the entire system. Then comes the technology diversity. Now, technology diversity means that your individual microservice can run in different programming languages or in different frameworks. For example, if let's say there are four microservices in your application, you can run one with Node Express JS, you can run one with Nest JS, you can run with Django, you can run with Flask, and it even has the possibility that if you want, if your application demands, then these four microservices will have their individual uh, databases as well. They don't have to share one single database, they can have their own databases. And another pro is that it has faster development. So basically, if let's say you will have multiple teams working on multiple features, and each feature will have its own service, so they're faster in developing the individual feature and as compared to one team building the entire project. Now, the challenges of microservices architecture is that it's distributed complexity. Now, managing multiple services requires expertise. One has to know what the other service has or doing if they are interdependent. Then there's the issue of data consistency. Inter-services communication complicates transactions. For example, if one service has updated something in their database or their application, then simultaneously if one of the other features is dependent on the first microservice, then they have to change those feature or write according to the dependent service. Now, operational overhead is another challenge in which you know that microservices spread out throughout the application. Now, what happens is if they are spread out, debugging becomes very difficult. So, to monitor, or we have to log more as compared to a monolithic architecture application. What happens is, like, for example, if a bug occurs, it takes, you have to understand from where the bug is taking place. Now, if no logging or no monitoring has been implemented in your app, in your microservice application, it will lead to issues when you're trying to debug the current bug. Now, I just want to show you diagrammatically what exactly the microservices architecture looks like. There are multiple ways how you can design your microservices architecture, but I'll go for one a very simple process. So, for example, you have some four microservices in which, let's say, one is your product service, one is your user service, one is maybe your order service, and one is, let's say, your payment service. These services have to interact each other to maintain the consistency of the entire application, which means that let's say they have different DBs. Okay. And so let's say when you register to any application in your application, you will be stored in your user DB. And then let's say you have ordered something, any product. Let's say you have ordered a t-shirt. Then comes your payment service. When you add your T-shirt to your cart, then you go to the payment service where you pay. Then there's a transaction going on that is also stored in your payment DB, right? Now, after the payment is has taken place, successfully taken place, that will be your order will be now stored in your order DB. Now, how will each service know what is taking place in your other service? For that reason, they have to communicate with each other. One of the most used ways that I have seen is by using a message broker. Now, these usually help in intercommunication of the microservices. Now, micro message brokers, we will learn more about them. But yes, I will say that one of the most common ways of designing a microservices architecture is by using message brokers. Now, when to use monolithic architecture? Monolithic architecture is usually used when you have limited, your application requires very limited complexity. For example, it's a small or a medium like sized application with like very straightforward requirements that you won't be adding more and more requirements later on. Then you go for a monolithic architecture. Then comes your rapid development. Monolithic architecture is, as they are used in a smaller and medium-sized applications, they're very easy to develop. They're not very complex because you just write a server, you write your APIs, and then you create a client side, and you just make them interact with each other via request and response cycles. Then comes your team size. Let's say if you have a smaller team and you're just starting any application, you generally go for a monolithic architecture because in the initial stage of your development, you don't require such big architectural designs if you have not thought of much. But generally, it when any small team starts an application, they usually start with a monolithic architecture to get going, and then if they require depending on what your demands or what your features or what your application is supposed to do, you either switch it to a microservices architecture or you keep having the monolithic architecture. After that, the it comes tight integration. When performance with a single database and tight component coupling are essential requirements, which means that you need all your data to be present in one single space and you need data to be consistent all throughout. You usually go for a monolithic architecture, which does not. So, for example, if let's say you're fetching some data from your database to send it to your client, now, if there are two different databases, it is possible that the data in your current services database might be stale. Now, monolithic architecture does not have that because monolithic architecture has a single database. So whenever any request response cycle goes on, it changes the data in the entire database wherever required. Now, when to use microservices architecture? When your application requires high scalability needs, like large complex applications requiring independent scaling and flexibility, that is generally when you go for a microservices architecture. Now comes concurrent development. Now, what concurrent development means is that let's say you have three features, and your three features, you can divide them into three different microservices. Now, what the benefit of this is that, for example, you've started, you designate three different teams to those three services, microservices, and they start developing. So it helps to realize that, yeah, okay, so they are, let's say, this first team, like first microservice is also developing, second microservice is also developing, third microservice also developing. So nothing stops. Now comes technology freedom. For example, let's say one of your services, there are later on read more about this, but just to sum it up, I want to say that let's say there is a feature which runs faster with GraphQL APIs as compared to REST APIs. Now, one, you can design your architecture in such a manner that one of your applications for that particular feature will use GraphQL APIs, and where REST APIs are faster, they will use REST APIs. Now, this is what technology freedom means. So, let's say if a team prefers having Django based server, or if a team prefers having Node.js based server, so they can also go for that. Now comes fault isolation. So let's say that your application has to run at all times, and you cannot have much like downtime of your application. All of that cannot take place. So you generally go for a microservices architecture. Why? Is because there is no single point of failure in your microservices architecture. If one service fails, you usually the other three services are handling somewhat of your application, and generally it does not take much longer to regain the downed microservice. And also there are other features in microservices architecture like redundancy and replication, all of that, which we will later on understand. Now choosing the right architecture is very important. There is no universal solution to what kind of architecture is the best kind of architecture, but definitely there's always this, that every feature or every uh, reason of creating an application has an architecture behind it. So if one application has needs that it has to run in a monolith because it works better in a monolithic architecture, then we go for a monolithic architecture. If you think that one application requires your microservices architecture because of, as I said earlier, that you don't need single point of failure or it has to run continuously, then you go for a microservices architecture. One thing I would say, that let's say if you are trying to build a proper application, then obviously everyone starts with a monolith architecture. Even Facebook, Netflix, Amazon, Uber, or even Spotify, all of them started with a monolithic architecture model. But eventually, when they realized that the load on their servers are much heavier, there are much more requests coming as compared to before. Now they had to scale their applications. What they did is they migrated from a monolithic architecture to a microservices architecture. What happened is that helped them to handle the server traffic much more easily as compared to before, when they were in a monolithic architecture. But if you're just starting your learning journey, then I would suggest that you start with monolithic architecture. You understand how the request response goes on between a client and a server. Then eventually you learn how to how to create a microservices architecture application. With this, the class is over. Thanks for watching. If you found this helpful, subscribe and stay tuned, because next I'll also create a Discord server in which you all can join, and you will share your applications if required, and we will review them together. So do like and subscribe. Thank you.